Assalamu alaikum, dear students. I am Ms. Sada Bahar, your physics teacher. I hope you all are fine and enjoying learning through e-learning classes. Well, dear, to step ahead, in the same Unit 10, Simple Harmonic Motion and Waves, dear, in today's presentation, I will explain conceptual questions and numerical problems from 10.1 to 10.4 of the exercise. The formulas used in solving the numerical problems are mentioned here in the start of the presentation. So, dear students, to proceed towards the topic, first of all, learning objectives of the lesson. Learning objectives. At the end of the lesson, students should be able to attempt all the conceptual questions and solve numerical problems using appropriate formula. Conceptual questions with answers. Dear students, first I will explain conceptual questions and then we'll do numerical problems. Question 10.1. If the length of a simple pendulum is doubled, what will be the change in its time period? Answer. As we know, the formula of the time period of a simple pendulum of length L is given by T is equal to 2 pi square root L divided by G. If length of the simple pendulum becomes doubled, that is, L dash is equal to 2 L, the time period will become T dash is equal to 2 pi square root of L dash divided by G, or T dash is equal to 2 pi square root of 2 L divided by G, or T dash is equal to under root 2 into 2 pi square root of L divided by G. Divide equation 2 by 1, we get T dash divided by T is equal to under root 2, or T dash is equal to under root 2 into T, or T dash is equal to 1.41 into T. So by double the length, the time period becomes 1.41 times of its initial value. Question 10.2. Answer. The motion of the ball is not simple harmonic motion because of the following 3 reasons. 1. In this motion, there is no equilibrium or mean position about which the ball has to and fro motion, which is needed for SHM. 2. In this motion, acceleration is not directly proportional to the displacement of the ball, rather acceleration here is constant, called the acceleration due to gravity. 3. Throughout the motion, the acceleration is directed towards the floor. Question 10.3. Answer. The time period of a simple pendulum is given by T is equal to 2 pi square root of L divided by G. As in the above formula, there is no factor of mass, so the time period of a simple pendulum does not depend upon the mass of the pendulum, therefore the time period for different masses are the same. Question 10.4. What types of waves do not require any material medium for their propagation? Answer. Electromagnetic waves do not require any medium for their propagation. Example of electromagnetic waves are radio waves, television waves, X-rays, heat, and light waves. Question 10.5. Plane waves in the ripple tank undergo refraction when they move from deep to shallow water. What change occurs in the speed of the waves? Answer. When plane waves in the ripple tank move from deep to shallow water, then wavelength of the wave decreases, so the speed of the waves also decreases, as according to the formula V is equal to F lambda, since frequency F is constant in both the regions, therefore V is proportional to lambda. Numerical problems 10.1. Given data, time period is equal to 2 seconds. G. on the Earth's surface is equal to 10 meter per second square, while on the surface of the Moon, g(m) is equal to g divided by 6, pi is equal to 3.14. Required data: we have to find the length of the simple pendulum on the Earth's surface and on the Moon's surface. Solution: on the Earth's surface, as formula for simple pendulum is T is equal to 2 pi square root of L divided by G. On squaring both sides we get L is equal to T square into G divided by 4 pi square. Now put the given values in the above formula. We get L is equal to 2 seconds whole square into 10 meter per second square divided by 4 into 3.14 square, or L is equal to 4 into 10 divided by 4 into 9.86, or L is equal to 1.02 meters. Same formula will be used for finding L on the Moon's surface. Only G will be replaced by G by 6, so the length on the surface of the Moon for the same time period will be 0.17 meters. Numerical problem 10.2. A pendulum of length 0.99 meters is taken to the Moon by an astronaut. The period of the pendulum is 4.9 seconds. What is the value of G on the surface of the Moon? Given data: time period is equal to 4.9 seconds, pi is equal to 3.14, length of the simple pendulum on the Moon's surface is 0.99 meter. Required data: we have to find the value of G on the Moon's surface. Solution: on the Moon's surface, as formula for time period of simple pendulum is T is equal to 2 pi square root of L divided by G. On squaring both sides we get G is equal to 4 into pi square into L divided by T square. Now put the given values in the above formula. We get G is equal to 4 into 3.14 square into 0.99 meter divided by 4.9 seconds whole square, or G is equal to 1.63 meter per second square. Numerical problem 10.3. Given data: length is equal to 1 meter, G on the Earth's surface is 10 meter per second square, while on the Moon's surface, g(m) is equal to G by 6, pi is equal to 3.14. Required data: we have to find the time period of the given simple pendulum on the Earth's surface and on the Moon's surface. Solution: on the Earth's surface, as the formula of time period of simple pendulum is T is equal to 2 pi square root of L divided by G. By putting the given values in the above formula, we get T is equal to 2 into 3.14 into square root of 1 meter divided by 10 meter per second square, or T is equal to 2 into 3.14 into square root of 0.1 second square, or T is equal to 2 into 3.14 into 0.316 seconds, or T is equal to 1.99 seconds or 2 seconds. Dear students, follow the same solution for finding T on the Moon's surface. Only g(m) will be replaced by G divided by 6. So, with this change, the time period we will get on the Moon's surface is 4.9 seconds. Numerical problem 10.4. A simple pendulum completes one vibration in 2 seconds. Calculate its length when G is equal to 10.0 meter per second square. Given data: time period is equal to 2 seconds. G on the Earth's surface is equal to 10 meter per second square. Pi is equal to 3.14. Required data: we have to find the length of the simple pendulum on the Earth's surface. Solution: on the Earth's surface, as formula for simple pendulum is T is equal to 2 pi square root of L divided by G. On squaring both sides we get L is equal to t square into g divided by 4 pi square. Now put the given values in the above formula. We get L is equal to 2 seconds whole square into 10 meter per second square divided by 4 into 3.14 square, or L is equal to 4 into 10 divided by 4 into 9.86, or L is equal to 1.02 meters. Dear, at the end, I would say, for you, you are somebody who wants to see a better world. You are somebody who wants to see that war ends, no poverty. Thanks.